We are the Black Soldier Fly Composting Smart Shed team. My name is Josh Noble. I'm one of the two electrical engineers on the team. And our goal with this project is to design a smart shed system that will enable Black Soldier Fly composting during the cold Rochester winters. The shed will feature a monitoring and control system to set the temperature, humidity, and CO2 levels for the flies. And since the shed will only receive grid power at night, we've also designed a solar power system to power the monitoring and control system during the day.
Hey everyone, my name is Adrian Huang. I'm a fifth-year industrial engineer, and my role on the team is the project manager. So throughout the first semester of MSD, like Josh was saying, we discussed the most logical way to split the smart shed into subsystems so we could distribute the work amongst the team. The final design, as you can see here, is our system level diagram at a very high level. It consists of three major subsystems: the Raspberry Pi board, computer operating the monitoring and the control systems. It also controls sensors, humidifier, the heater, and the vent. We have our solar power generation system to supply energy to all of our equipment. And here we have a dashboard made in Excel to query the data, sort through it, and display the metrics remotely from any one of our customers' like home laptop or computer.
Hi, I'm Samina Moa, and I'm also one of the other fifth-year industrial systems engineers. My role is the communications with the stakeholders. For our past Black Soldier Fly teams, the proposed layout was done, so we know that the main items we want in the shed are the fan to cool down the shed, the battery inverter from the solar panel, the humidifier to increase the humidity levels in the shed, breeding area for the flies, the sensors for the temperature, humidity levels, and CO2 levels, PI system for the sensors, the power system for the entire system, and the control panel for monitoring and data collection.
My name is Michaela Navel. I'm one of the electrical engineers on the team, and I'm also the purchasing agent for the team. So at the shed, concrete footers were needed to secure the solar panel structure, and these were dug and poured in December. In February, the brackets were attached to these footings. The legs for the structure were drilled and secured, and cross bracing was added for extra stability. The brackets and rails for the solar panels were also attached to the legs at this time. Back on the MSD floor, the wiring for the panels and power system components was prepped. The panels were then mounted and the conduit was installed. Finally, the charge controller, batteries, and inverter were wired up inside the shed.
My name is Jenica Haining. I'm a computer engineer, and my role on the team is a systems engineer. In order to maintain the environment for the flies, we needed to monitor data from the shed using sensors designed to collect information such as temperature, humidity, and carbon dioxide levels. With that data, we determined when it's necessary to turn on or off the devices, such as the heater or the humidifier. This is automated using the Raspberry Pi to reduce the need for human interference by connecting the Pi to the relays that control the devices. The software for this is written entirely in Python for ease of understanding. We did encounter an issue related to security. A remote connection port on the Pi was open to allow team members to work remotely. Unfortunately, a third party logged into the Pi and installed unwanted malware. This was, however, quickly remedied by resetting the Pi and installing additional security measures.
For our vision, we hope to have a working system for the shed with minimal issues. And we also want to have a dashboard to be able to show the long-term data of the shed environment in terms of temperature, humidity levels, and CO2 levels, as well as analyzing the differences in those levels changes for each day, so that way we can spot any issues for troubleshooting. With this kind of data, this will allow us to determine the feasibility of the composting system in Rochester weather conditions.